Assalamu alaikum. Have a good day. Welcome to Financial Management eLearning. We are in Computer and Information Technology paper, BBA Accounting second year under the National University. Module 1, Part 2. Today we learn number system, computer organization and architecture, basic logic gate, and truth tables. Number. When we type some letters or words, the computer translates them in numbers as computers can understand only numbers. A computer can understand the positional number system where there are only a few symbols called digits, and these symbols represent different values depending on the position they occupied in the number. The value of each digit in a number can be determined using the digit, the position of the digit in the number, the basis of the number system, etc. If you see here, number system, there are decimal number, binary number, octal numbers, and hexadecimal numbers, decimal numbers. The number system that we use in our day-to-day life in the decimal number system, and decimal number system base of 10 as it used 10 digits from 0 to 9. Look here in the system, successive position of the left of the decimal point represent units, tens, hundreds, thousands, and so on. Is the 0 is a 1, power of 10, 1 that means tens, 2 is 100, thousands, 10,000s, 100,000s, million, 10 million, and so on. For IT purpose, we need the following number system. One is binary number system that is a base of 2 and digits use only to 0 and 1. An octal number system, base 8, digit used 0 to 7. That means total 8. Hexadecimal system, base 16, digit used 0 to 9 and later A to F, total 16. If we see the binary number, characteristics of the binary number systems are that use two digits 0 and 1, also called as base 2 number system. Its position in the binary number represents 0 power of the base 2. Each number called bit, and 8 bits equal to 1 byte. Let's take example, a binary number 10101. We are going to calculate in decimal equivalent. This binary number we can represent this way. For example, this 1 multiplied by 2 base 0 power and 0 multiplied 2 base 1 power, 1 multiplied 2 base 2 power, 2 base 3 power, 2 base same way. So we'll get in the decimal figure this one, and total number would be that means 21. So normally we write this way. Now octal number system. Octal numbers is 8 digit 0 to 7. That means 0, 1, 2, 3, 4, 5, 6, 7. It's also called the base 8 number system. Its position of an octal number represent a 0 power of the base 8. So look here in the right side, binary number and octal numbers in the difference between both. If binary 111 is the octal is 7. Now we'll convert this 12570, the octal number, equivalent to decimal number. How? Look here, as same as binary number, we put the figure in all here. That means this 0 multiplied by 80 to the power 0, 7, this 7 to the power 81 in the same way. So we'll get 5496. Now what's the decimal system? Here total 16 base. His base is 16. Is a base 16 number system. 10 digit and 6 letters. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Total 16 numbers. The letter represent the numbers starting from 10. That means A equal to 10, B equal to 11, C equal to 12, D equal to 13, E equal to 14, and F equal to 15. So each position in a hexadecimal number represent a 0 power of the base 16. Here, 19 FDE, the hexadecimal number, if we convert is the decimal number, then we'll get this figure, the same as previous we did it. Total, this is the decimal equivalent number. So it is easier. We can calculate it binary to octal, octal to binary, hexa to binary, hexa to decimal, etc. Now, computer organization and architecture. Architecture of a computer defines the manner in which the hardware components in the system work to meet functional objectives, and enabling this hardware component to work in a harmonized manner is called computer organization. Starting with the structure and functioning of CPU, it then discusses with the operations performance on the structure and use data. Further, the communication among the processor, memory, and input-output device is explained. Look here, computer architecture attribute the visible to the programmer, and organization how features are implemented. That means control signal, interface, memory technology, etc. And that is there is a hardware multiplier you need to that down by the repeating addition. So in this architecture, there is high level and low level, and where the software, hardware, the application program, application design, system design, computer design, logic design, circuit design, computer component, so the total computer structure. Now, if we see the computer component, the taken unit is to device, processing data, output information, control, and workflow. The input, the process of entering data and instructs into the computer system, and store data, saving data and instruction to that they are available for processing as and when required. Processing data, performing arithmetic and logical operation on data in order to convert them into useful information. Output information, the process of producing useful information of result for the use, such as a printed report or visual display. Control the workflow, directs the manner and sequence in which all of the above operations are performed. So if you see here, the CPU combined a memory unit, control unit, arithmetic and logic unit, and here we are inputting units and output units. Input units. This unit contains device with the help of which we enter data into the computer. This unit creates a link between the user and the computer. The input device translates the information into from the understandable by the computer, and input devices, mouse, keyboard, light pen, scanner, graphics tables, microphone, barcode scanner, barcode reader, optical marker reader, etc. All are the input device. CPU means Central Processing Unit. CPU is considered as the brain of the computer. CPU performs all types of data processing operations. It stores data intermediate result, and instructions and program. It controls the operation of all parts of the computer. CPU consists of the CPU is considered as the brain of the computer. CPU perform all types of data, stress, control, operation of all parts of the computer. CPU itself has three components. One is arithmetic logic unit, memory unit, and control unit. Memory or storage unit. This unit can store instructions, data, and intermediate results. This unit supplies information to other units of the computer when needed. It is also known as internal storage unit, or the main memory, or the primary storage, or random access memory, that is RAM. Its size affects speed, power, and capability. Primary memory and secondary memory are two types of memory in the computer. Is the primary memory, secondary memory. Primary memory is RAM, random access memory. Secondary memories, look here, hard disk, cache memory. CPU is the processor. If you see about the memory, there are various units which are used to measure computer memory. Bit, smallest unit of the computer memory. Byte, 8-bit equal to 1 byte. Kilobyte, 1024 byte equal to 1 kilobyte. Megabyte, 1024 kilobyte equal to 1 megabyte. Gigabyte, 1024 megabyte equal to 1 gigabyte. That which we are calling as GB. Terabyte, 1024 gigabyte equal to 1 terabyte. We can see here memory. One is read-only memory, ROM, another random access memory, RAM. Memories are programmable read-only memory, erasable programming read-only memory, electrically erasable programming read-only memory. And RAM, also stacked RAM, dynamic RAM. All are the memory here. Look here. Memory is another two types, internal and external. Internal, RAM, cache, sequential access, virtual, and ROM. External, solid state, magnetic, and optical. Control unit. This unit controls the operation of all parts of the computer, but does not carry out any actual data processing operation. Machine cycle, their main memory is to the fastest first instruction from the memory goes to the control unit. And second, decode instruction into command in the machine cycle. And third, execute command ALU. And fourth, store result in memory. So function of control units are, it is responsible for controlling and transfer of data and instruction among other units of a computer. It manages and coordinates all of the units of the computer. It obtains the instruction from the memory and directs the operation to the computer. It communicates with input-output device for transfer of data or result from storage. It does not process or store data. Now, arithmetic logic unit. Look here, is the memory unit, arithmetic logic unit. Within the arithmetic logic unit, accumulator, logic circuit, resistor, and here is the control unit. So arithmetic logic units, there are two subsections. One arithmetic section, another logic section. Arithmetic section, function of arithmetic section is to perform arithmetic operation like addition, subtraction, multiplication, and division. All complex operations are done by the making repetitive use of the above operations. Function of logic section is to perform logic operations such as comparing, selecting, matching, and merging of data. Now output unit. The output unit consists of devices with the help of which we get the information from the computer. This unit is a link between the computer and the users. Output devices translate the computer's output into a form understandable by the users. Output devices monitor, printer, etc. Input device, output device. Basic logic gates and truth table. The basic logic gates are classified into 7 types: AND gate, OR gate, XOR gate, NAND gate, NOR gate, XNOR gate, and NOT gate. The truth table is used to show the logic gate function. All the logic gates have 2 inputs except the NOT gate, which has only 1 input. What is the principle of logic gates? Each type of gate has 1 or more input and 1 output. The principle of operation is that the circuit operation on just 2 voltage levels called logic 0 and logic 1. Why logic gates are used? Computers need a way to manipulate those ones and zeros so that they can eventually do more complicated operations. Computers use logic gates to transform the ones and zeros from the input wires. A logic gate accepts inputs and then outputs a result based on their state. Basic logic gates with truth tables. Input AB, that output A into B. That means AB. If we see the truth table, a truth table is a logically based mathematical table that illustrates the possible outcome of a scenario. The truth table contains the truth values that would occur under the permissions of given scenario. As a result, the table helps visualize where an argument is logical or true in the scenario. If input A0, B0, output 0. If input A0, B1, output 0. Input A1, B0, output 0. If input A1, B1, output 1. Who use truth table? Mathematics normally use a 2-valued logic. Every statement is either true or false. We use truth table to determine how the truth of a complicated statement depends on the truth of its components. Each gate has an opposite or complementary form of its in the form of AND gate, the NOR gate, and the buffer representatively, and that any of these individual gates can be connected together to form more complex combinational logic circuit. Digital logic gate can be made from discrete components such as resistor, transistor, from RTL, resistor logic, or DTL circuit. The 8 most standard individual logical gates summarize. Standard logic gates are the logic AND gate. Symbol is that 2 input and digital logic gate. And Boolean expression Q equal to a B. That means truth table would be this one. This is the logic OR gate. We read as A or B gives Q. Here A0 or B0 and Q0. In the last line here A1 or B1 and Q1. Boolean expression Q equal to A plus B. The logic AND gate we have to read this way A and B gives not Q. And here, Boolean expression Q equal to AB. And the logic NOR gate, we have to read under the truth table, A or B gives not Q. Here, Boolean expression Q equal to A plus B. And the exclusive logic gate, the logic exclusive OR gate, that means XOR. We have to read as A or B, but not both, gives Q. That means OR. Here, Boolean expression, this. The logic exclusive NOR gate, XNOR. We have to read if A and B, the same gives Q, that means even. And here is the Boolean expression. Now single input logic gates, the hex buffer, where the symbol is that, and Boolean expression is Q equal to A. And we have to read as a truth table, it is A gives Q, A 0, Q 0, A 1, Q 1. The NOR gate inverter, your Boolean expression Q equal to not A or A, read as A gives Q. The operation of the above logical gates and their Boolean expression can be summarized into the single truth table as so below. Look here, this is summarization of the input, truth table, output, each gate. This is the summary of you. This gate, and this summary is the truth table output for single input gate. Here pull up and pull down resistor. One final point of the remember, when connecting together digital logic gates to produce a logic circuit, any unused inputs to the gate must be connected directly to either a logic level 1 or a logic level 0 by means of suitable put up or put down resistor. This is the picture of pull up resistor, and this is the pull down resistor. Look here. In this picture that we are finding logical circuit shown in the figure. A, BC. In this first gate, this comes with B, that is AB whole bar. Here, in this first gate, BC whole bar. And in the second gate, this A comes here, that means A bar. And same way in the C bar, in this way, here, AB whole bar plus BC whole bar. So in the third gate, this total, which comes here, that is Y equal to A bar plus AB whole bar plus BC whole bar plus C bar. And this figure, A bar, this AB whole bar equal to A bar plus B bar, and BC whole bar equal to B bar plus C bar, and C bar here. So this we can write here this way, A bar plus B bar plus C bar. So what is the answer would be Y. Y equal to A bar plus B bar plus C bar. So all for today. We will meet with you with my second module. So today we discuss number system, that means decimal number, binary number, octal number, hexadecimal number. Then computer organization and architecture, that means memories, arithmetic logic unit, CPU, input device, output device, etc. And we discuss basic logic gates and truth tables. Inshallah, we will meet with you again with my second module. Till then, Allah Hafiz.